Hi, I'm Andreas from Kitex. Today I would like to show our TWT-11 wind turbine. This is a turbine for households and farms that you can use to heat your home and charge your car. And this is about 15 meters high and weighs about 300 kilos and can be installed really easily. And it has pitch control, so it can control the power even if it's low wind or high wind. You can get optimal performance. The turbine power is produced up there with the generator and then sent to the inverter that we have over in the gray trailer over there. In the inverter, that also has a battery, so you can store the electricity, which then can be sent to, for instance, your electric car, and you can charge it. So you can charge with 11 kilowatt from the battery, or you can reduce the charge rate to about 4 kilowatt, and then that matches the power output of the turbine. So let's go over and see how the inverter and power production looks like. And one of the cool things that we really optimized the turbine design for is the low noise. So because we have a really low tip speed and a pitching blade, it doesn't make much noise. And let me show you the inverter and what else we have in here. So this is, you can come on in if you can, but this is the inverter that takes the DC input from the wind turbine. And here you can see we're currently producing about 3.5 kilowatt from the wind turbine, which then goes to the battery. And here's the battery next to it. This is the smallest version we have with about 9 kilowatt hours of energy storage. And then rest of this is mainly test equipment, because this is at a test site. But this is what you would have. And then if you have a battery, then it's this. We actually also, over there in the back, we have the grid tie version. So if you don't want the battery, then you can get this one instead. And now we can go to check out the car. So basically from the, you could say inverter, we just ran an extension cord, but this would normally just be a cable in your home. And then we have this, I think it's called a level 2 EV charger, then plugs into directly into the car. And now we're just gonna show that it actually is charging. It's not the easiest display to check, but it looks like it's set to 6 amps and it measures 4.8, so it's 3.9 kilowatt. It says charging. So while I'm out here, I would like to show you a little bit more about the features of this turbine. And one of the things that makes this turbine special is that we use guy lines. So these are the guy lines. They are lines that hold the forces in the tower. And the guy lines come down and then they are connected to a, what do you call it? Ground screw. So this is like a screw. This is a big screw that you just screw into the ground, so there's no concrete foundation. And we can screw this one in about 10 minutes time. So it's really easy to build the foundation. And then these lines are made of, some of them are Dyneema, some of them are steel, but they are incredibly tough and lightweight and easy to use. And here you can see the vent screws, which is basically a steel contraption that you use to adjust the tension in the line. So the design is such that it can be installed once, and then you need to tension it the day after installation, but then actually the tension will last for 1 year. And then after that initial year, then it will be several years between the tension operation. One of the really interesting parts of our turbine design, or that's very different, is actually the whole top tower of the turbine rotates with the rotor and nacelle. And another big difference, which is also why this sort of makes sense, is that it's a downwind turbine. So the blades are on the opposite side of the tower compared to a conventional turbine. So you can see the conventional turbines in the background, and they point with the blades into the wind, whereas ours is on the back. And what this also gives us is that due to the unique geometry and control of the blades, then it's self-stabilizing in the yaw direction. So we don't need a controller or actuator to find where the wind is. The turbine does this by itself. And then right now on the top of the turbine there is some additional testing equipment. For instance, there's a camera up there that we have on a pole, and also the generator and electronics will be covered with a cover or fairing. But since this is a prototype turbine, we haven't installed it since we need quick access to the various electronics and so forth. And then you can see on the arm itself there's 2 slider rings, and these rings move back and forth, and they are done or made in such a way that when they move away from each other, then the blades turn. So this functions a bit like a swash plate on a helicopter, but in this case it's just for our turbine. The turbine, most of the structure is made of fiberglass or glass fiber, a bit like the wings on the large turbines. And one of the main advantages of the glass fiber is that it's really lightweight, so it's easy to install, but also it has a very good environmental performance, so it can last for a really, really long time, most likely 30 years without any corrosion issues. And then we do have in between some plastic parts and the lines themselves, and they might need replacement after 10 years. But we'll have to monitor that situation as the turbines gets older. Yeah, what else? Yeah, then another part that makes our turbine unique, maybe you need to come around to the side to see it, but that is that our turbine has a belt drive. So let's just go around. We need to go quite a distance. But the gearbox is made with a belt as a gear reduction stage, and the belt or gear reduction, as you can see it here, is a beneficial design choice in that the way it's designed, it takes some of the actual axle movement or wobble from deflection and removes that basically wobble, and it doesn't go directly into the generator shaft, so it's really nice for the bearings that we don't have these loads, and also it means that we can make this larger pulley that's driving the generator relatively cheaply. And also compared to a direct drive turbine, the generator itself can be about 3 times smaller, or six times smaller, sorry, which of course saves cost and mass and environmental impact. So yeah, that's the main parts of this design. Another thing that maybe is worth noting is that the turbine has 4 guy lines, and that has been chosen such that it's relatively easy for us to raise and lower the turbine, which then facilitates that you can access the blades and change them if needed on the ground. And also you can lower it all the way such that you can get to the generator and electronics, and for instance also change the belt in the gearbox. So actually you cannot really climb this turbine, it's not designed for it, and we wouldn't recommend to do it. So you always have to lower it to services and access it. Then the last thing, and maybe the last thing that I would like to talk about today, another thing with this turbine, in one sense it's quite modern, that it uses modern Wi-Fi connected or 4G connected controllers. So we do gather a lot of data from the turbines, which can then be used to diagnose any potential issues in the turbine itself, which means that we can reduce the service intervals and only come out and service the turbine when you need to have it serviced, basically.